Hello and welcome to today's webinar on the topic of revolutionary image evaluation in hardness testing with AI technology. My name is Thomas Stromer and I'm pleased to guide you through this exciting topic of artificial intelligence in the hardness testing today. In today's world, where technological advances are profoundly changing our daily lives and industry, artificial intelligence is playing an increasingly important role, especially in hardness testing. AI offers innovative approaches to make processes more efficient, precise, and reliable. The topics for today's webinar. We will look at the theoretical basics, what is artificial intelligence, as well as practical applications, especially the areas of application. From this, we will show you some examples that are now possible through the integration of QAI. Finally, we will answer frequently asked questions from the last few months regarding AI or regarding the use of AI. What is artificial intelligence? AI stands for artificial intelligence, of course, is a software-based system designed to simulate human cognitive functions. This technology can recognize patterns, understand language, make decisions, and learn from the data or used feedback. AI systems are already an integral part of our everyday lives. Examples for that is, for example, a robotic vacuum cleaner. Modern robotic vacuum cleaners use AI to navigate and clean more efficiently. They are able to create floor plans of rooms and move optimally through the rooms, recognizing and avoiding obstacles. Often we don't even constantly realize how much these technologies influence and facilitate our daily routines. There are like different groups for the AI concept. We are focusing 3 different groups out of them. The first one is the data-driven AI. These data-driven approaches in which algorithms learn from large amounts of data to recognize patterns and make predictions. Examples include image and speech recognition systems that learn from training data to improve their accuracy. The second one will be the rule-based AI. These systems are based on predefined rules and logic developed by human experts. The use of knowledge based on rules engine to draw conclusions to make decisions. Rule-based systems are especially useful in areas where decision making is clearly defined and well structured, such as medical diagnosis or financial analysis. Evolutionary AI is the last part of the concepts of AI. Those algorithms are inspired by biological evolution and use mechanisms such as selection, mutation, and crossing to develop solutions to complex problems. They are particularly effective at optimizing and problem solving in dynamic environments. Each of those concepts has its own strengths and areas of application, and choosing the right approach depending heavily on the specific requirements and goals of the project. Data-based approaches are particularly effective when large amounts of data are available. Our system is subordinate to the database category inside the deep learning, which relied on data from indentations. Inside the data from indentations, we will have a look to the object The object that the recognition is revolutionizing the hardness testing by delivering faster, more accurate, and intelligent the results. With the integration of the AI, the future of hardness testing is setting a new standard, we can say, regarding the precise and the efficiency of the AI model to evaluate Vickers, Brinell, and Knoop indents. As you can see on the left-hand side, targeting optimization increases performance and automatic detection of unparalleled accuracy and higher hit rates. These advances enable precise and reliable material analysis, which is significant improve of the quality of the indents. Now I'm going to show you a diagram which is divided into different areas that depict the quality of surface preparation. From the left side we have the good qualities, to the right side the bad conditions, we can say. In green, the hit hitter conventionally evaluating by the algorithm as conventional evaluation. In purple, the QI evaluation, we can say. From the left to the right, the quality of the surface decreases, as I mentioned before. With already edged surfaces, you can see the standard evaluation decrease completely, and the purple evaluation area for the AI is inside like 99-98% of finding the correct reliable indent. Through this advanced analytical capability, QI overcome to the challenge posed by poorer surface conditions while still delivering accurate results. Here is clearly evident that the QI increases the quality of the detection of hardness test indentations, especially for the demanding surfaces. The QAI technology is based on a comprehensive training database, which has been continuously expanded by creating numerous of indents. Each test method of those, especially Vickers, has been carefully tested to ensure the QI accurate and reliable. Different surfaces were explored to maximize the versatility and adaptability of the QI system. This thorough preparation allows QI to achieve exceptional accuracy and efficiency in hardness testing. Now I'll show you a surface of different materials, edge surfaces, standard surfaces, and surfaces with a lot of pores inside, or with a clearly structure representative of the material of the preparation. Now I have a question. What do you think? Can we evaluate such surfaces with the evaluation system if we are going to hit one indent inside the surface? So maybe you can think about it for a sec, and I will give you an answer later inside the webinar on a later point of view. This, for example, is an edged sintered tooth surface. This one would be a graphite cast iron. This would be also a different edged surface, and one of a weld seam. The last one would be a guided rail. So what do you think? Can we do some indents on these surfaces and evaluate it 100% automatically? We'll see later on. Why? I'm going to show you these kind of pictures to give you an access to our development of the system, designed precisely for those structures, we can say, for those surfaces. This means that the integration of the QAI, where a processing have been integrated only after a sample has been checked. Here you can see a list of the steps till we set an impression, starting with the hardness tester and the sample of testing, of course. We need an operating software to define the pattern. After test, we are going to hit the indent and start evaluating. After evaluating and save the image, our QAI will be running. So we use the existing indent and evaluate it with our new technology, we can say. As you can see, for example, there is the first result. So the evaluation will be done fully automatic. We can find the edges, so the evaluation is reliable. The green lines are directly at the corner of the indent, so we get a nice result of 148 HV with the method 1 kilogram. The evaluation is carried out with our operating software Cubix Control 2 and Cubix T2, depending which kind of device you're using. This integration enables seamless and efficient processing of the measurement data. QAI principles are designed to provide a reliable and secure platform for the evaluation of measurement data. QAI is a completely offline solution that does not require an internet connection to perform a test. All data are stored locally and processed locally, which ensures the highest level of data security. There is no need of continuous adjustment of the QAI of the machine. There's one verified software which is running on your device. Now I'm going to show you some different improvement of the indent itself. So the QI improvement process starts with the passing on an impression of a difficult surface to QATM. For example, if the evaluation is not running good. The experts of QATM will carefully analyze this impression and integrate it into the evaluation strategy for the QI system in the future. The new evaluation approach is verified from our side to ensure that the evaluation meets our standard requirements and provide accurate results. After that, we can optimize the evaluation process with the QAI with an update and extensively test it to ensure the functionality and reliability. Finally, we can update those systems to the standard devices for automatic evaluation and efficiency. After that, the improvement of the accuracy is done, and we can fully automatic evaluate the indent, which was sent from the customer. Now I want to present you an excerpt which we have prepared on edged surfaces on a guided rail. On the upper corner, we make a CHD test series. As you can see, the second sample is a Hardness gear, also been edged, where we do some tests fully automatic with our system. The third component has the layer and partially edged and unedged areas where we make some indents all over the test points, all over the sample. The test was carried out with 50 grams and 1 kilogram. The evaluation is fully automatic and the reading with the QI is completely accurate, that the lines are 100% on the edge, on the corner of the indent. The fourth component is a normal tooth flank, which was standard polished, and we're going to run a standard test series on a responsible position with 1 kilogram. As you can see also on the standard evaluation surfaces, it's running good. The fifth component is a cast iron with some graphite. We make some visual test points all over the sample, and also on different contrast of the surface, we can run an automatic evaluation. The sixth component is also an edged weld seam sample where we make some tests on the responsible zones in the weld seam zone, heat affected zone, and ground material. There we see the ground boundaries and also the evaluation, in this case also fully automatic, done from the software. The last sample, the seventh component, was a carbide coating with a test force of 50 grams, and we make several indents on this coating. As you can see, the indent is really small, less than 10% of the diagonal, and the software automatically evaluates those indents. So it doesn't matter the size and the part where we're going to hit the indent, the software can fully automatic and reliable evaluate those indents. Now I will answer the question I asked before, whether we can evaluate such surfaces with the conventional evaluation technology with 1 kilogram or with the artificial intelligence. My answer for that is clearly yes, we can do the evaluation with the QAI solution on such surfaces on a reliable function. I will now show you the hardness impressions from the different surfaces which I shown you before. This is the first one on a sintered tooth flank, which is also edged. So we have a lot of different contrast of the material comparing to the indent. It's really hard to see the corners, but the evaluation is 100% correct on the responsible position, we can say. The next one would be the cast iron with the contrast of the pores. So the software will also found the corners on a good way, and it looks really, really good. The next one would be some edge surfaces, also where we see the grain borders, and it's really hard to see also the corners visually, but the software can find also indents on such surfaces. The next one will be also edged weld seam measurement with 1 kilogram. So we've also like less contrast of the indent to the ground to the material, but the software can also find these kind of indents. The last one would be also an edged guided rail on a method with 1 kilogram. Looks also quite good. A different application for that would be also like the mapping. If you have like this is like a major advantage if we're using the AI evaluation regarding the hit rate. So in this case, we have a mapping with over 3,239 test points selected on the part, which was testing during the night over a couple of days. We make an impression rate of 100% was achieved on this solution. This is quite good. So we get rid of the remeasure. We get rid of losing time for controlling the indents. So this is one of the best advantages we can say for inspection. On the top left, you can see the impression with the 1 kilogram load. So evaluation is fully automatic, reliable, and accurate. On the top right, you see the 2D mapping of the whole sample with the different colors of the different hardness values. And on the bottom left, you see the 3D animation of the part. In this test, we make some comparison of a hardness reference plate with 700 HV. We make a test method with 1 kilogram. We evaluate two different systems, the standard classic rating comparing to the QAI. Both methods analyzed with the same 19 indentations, but of course with different evaluation ratings. The scoring range has improved significant, as you can see in the gray marked, from 24.9 to 16. And of course, in addition to that, the standard deviation was almost halved and shown on the second side from 5.8 to 3.4, which confirms a higher reliability and consistency in the measurement results. These improvements underscore the efficiency and accuracy of the QAI evaluation of traditional approaches. The advantages described above lead to a significant improvement in the overall testing process. The increased hit rate and accuracy ensures more precise and reliable results. while the increased repeatability ensures constantly of measurement. By automating the process, human error is minimized and efficiency is increased. At the same time, there is a reduction in the deviation which further improves the quality of the evaluation. The time saved and the reduced need for manual reviews results in a learner and more cost-efficient execution of the checks. Now, I want to give you the most frequently asked questions. I want to go through these questions and give you also the responsible answer. Does the hardness tester need to be recalibrated after updating and using QAI? The answer is no. There is no recalibration necessary. Why not? Because we do not change anything of the optical system. Or we do not change anything of the camera, the lens, the magnification. Everything is unchanged. The AI is only captured the image which was saved from the system. And then we're using the evaluation only. Therefore, it's not needed. The second question, is there a specific requirement for sample preparation in connection with the QAI? The answer is no, because there are no relevant standards for preparation and also no relevant standards regarding the surface quality and roughness. In general, the surface for Vickers testing on microload and nanotechnology has to be good, right? So you have to prepare the samples depending on the applied load. The indentation should be clearly seen and the edges must be clearly visible to do an automatic evaluation. Next question, can the preparation effort for the use of AI be reduced? Possibly yes is the answer. Why possibly yes? Because it depends. Regarding the AI, image evaluation can be detect hardness impression on surfaces of lower quality, but it really depends, as we had on the previous question, that the corners have to be visible. So maybe we can have a look to reduce one or two steps regarding the roughness, regarding the scratches on the surface. This could be possible. Therefore, you can make some checks by yourself directly if there is an effort. It is possible to carry out a hardness test on edged surfaces. Answer is yes. As you can see on the previous slides, I showed you a lot of edged pictures of indents where we're doing the test fully automatic and reliable. Also, the mapping with a 100% hit rate was done on edged surfaces with 1 kilogram. Does the QAI require an active internet connection? This is also a common question. I answer also during the webinar. Answer is no, there is no internet connection necessary. The AI is stored locally on the PC of the software. So there is a verified evaluation saved in the software, which is working on a proper way. So there is no internet connection for doing that. Can the QAI change independently? No, the QAI model cannot develop and learn independently. It's a verified released version which is saved on your system inside the software. If you want to optimize the impression, then we can do the improvement steps to send the project to us. We make a test, clearly make the development of the different surfaces, verified and update the system overall. If you need further information of the QAI, you can directly go on the QATM homepage. There are like all topics related to QI noted, all products on software information you can find directly under more information on the homepage. If you have any kind of questions about the QAI, please feel free to ask directly in the chat, or you can use the application.at@qatm.com, and we are going to answer your question as soon as possible. We will be there for your in the next few minutes inside the chat for answering your questions. If there is no questions, I want to say thank you for your attention and wish you a pleasant working day.